Assalamualaikum and good morning. My name is Nurul Izzati binti Abdullah from program AS244. I would like to present my final year project titled Potential for Isopolysaccharide produced by Probiotic Consortium during cultivation in rice water as heavy metal quencher in drinking water. To briefly explain about my project, I will divide today's presentation into several parts. Mass urbanization, agriculture activities, industrial expansion, and the release of nuclear waste have caused heavy metals to contaminate the environment, thus causing pollution for human health. However, bioremoval and bioabsorption using microbes are known to be the best methods for inexpensive scale-down of bioavailability without losing water quality. We believe that the isolation of beneficial probiotics from environment samples and intestinal contents is one of the promising techniques in bioremediation. Isopolysaccharides in these probiotics will act as mediator that interact with positively charged metal ions and negatively charged biofilm in EPS. The main concern of heavy metal contamination is that the metal discharge of urban runoffs and industries tend to accumulate in water reservoirs and alter the environmental pH and temperature of the water. This will cause water to be toxic to the ecosystem, animal, and humans. The conventional chemical treatment technologies are unable to treat contaminants such as carbon, nitrogen compounds, and heavy metals effectively. The significance of this study is that this study will explore a potential application of a combination of probiotic as biosorbent to remove bioavailability of water contamination. With more advanced study in this field, the chemical technologies in water treatment might be fully replaced with biological technologies in near future. Two main objectives of this study are to determine EPS production by probiotic consortium during cultivation in rice water medium and to study the effectiveness of EPS in degrading heavy metals as heavy metals quencher in drinking water. According to Shah et al. 2014, their study showed a higher heavy metal concentration found in Tembe River. Downstream water has a larger quantity of zinc, chromium, copper, cadmium, iron, manganese, and lead than the upstream water. It is due to the disposal of wastewater, untreated sewage, and solid waste in river. Another study from Sankla et al. 2019 reported that an excessive amount of zinc in human body may cause premature aerial strokes and hypertension subordinate. Hence, Evanco and Zomba et al. 1997 used microbes as one of bioremediation approach in the process of degrading, removing, altering, and detoxifying contaminants from groundwater to turn into carbon dioxide. The latest study made by Ling et al. 2020 also showed a positive effect where gut microbes in intestinal were significantly decreased after being exposed to lead, indicating that these microbes absorb and accumulate lead to reduce its toxicity in host cell. The increasing of probiotics can be optimized by culturing in rice water media as reported in a study, Kalaram Populus et al. 2003. Rice has the potential to promote growth of lactobacillus species and bifidobacterium as well as increase their availability under gastrointestinal condition due to its rich carbon source. The methodology includes the isolation of probiotic consortium, namely Lactobacillus acidophilus, Lactobacillus rhamnosus, Lactobacillus plantarum, Lactobacillus casei, and Bifidobacterium pseudocatenallatum. To complete the first objective, we cultivate probiotic consortium for EPS production in rice water medium. Then we extract and purify the EPS using dialysis tube filtration. To relate with objective 2, we remove heavy metals from drinking water by EPS by mixing 1 ppm of heavy metals, 2.5 ml of EPS, and 7.5 ml of drinking water. Finally, we determine the removal efficiency using ICP-OES. In comparison of 4 heavy metals, zinc has the lowest remaining metal concentration, indicating that the bioabsorption of zinc by probiotic consortium is high. In contrast, arsenic showed a higher remaining metal concentration with reading 0.239 mg per liter. We reported that the low uptake of metal by probiotic consortium may be due to an increasing in contact time during the process to more than 24 hours, thereby decreasing the effect size and removal efficiency for arsenic. Following ICP-OES analysis, we presented a graph of removal efficiency of heavy metals by probiotic consortium grow in MRS broth medium versus rice water medium. A range of 70% to 90% removal efficiency rate of heavy metals by probiotic consortium grows in rice water were observed. The growth of probiotic consortium show a higher removal efficiency result in MRS medium compared to rice water medium. The result indicate a higher EPS concentration produced by NAB during the cultivation in MRS medium compared to rice water medium. The study reported the effectiveness and critical criteria that govern the process of heavy metal removal using microbiome biomass as a new method for decontamination of drinking water. We successfully screened potential EPS produced by probiotic consortium. The order of EPS effectiveness for heavy metal removal was zinc, lead, cadmium, and arsenic. Among all samples, zinc showed a higher removal efficiency of 97.9% compared to other heavy metals. Researchers may conduct further studies to discover the effect of different concentration of EPS on heavy metals removal and the interaction between EPS and heavy metals.